Welcome to this explainer. Look, if you are studying Cambridge computer science, whether you're building foundational knowledge in syllabus codes 0417, 0478, 0983, 0984, 2210, or pushing into the advanced territory of our main focus today, syllabus 9618, you already know that translation software is absolutely foundational. But let's be real for a second. Today, we aren't just sitting here memorizing textbook definitions of compilers and interpreters. That's what average students do. Instead, we are completely transforming your basic theory into an absolute, bulletproof A-star exam strategy. I want you to imagine two completely different students walking into the exam hall. Let's call them Alex and Sam. Alex is the kind of student who overloads their exam answers with raw computer science facts. They know every definition, but there's absolutely no critical analysis in their response. Then you have Sam. Sam rushes through the paper, completely misses the specific command word requirements, and ends up losing easy marks because they just didn't structure their answer correctly. By the end of this explainer, you are going to know exactly how to avoid the traps that Alex and Sam fall into and how to write answers that practically force the examiner to give you top marks. To set the stakes right out of the gate, I want you to listen to this quote straight from a Cambridge senior examiner. They said, "The difference between a B and an A-star in computer science often comes down to how well you understand compiler versus interpreter, benefits and drawbacks." Think about that for a second. You might think that incredibly complex coding problems or obscure hardware architecture questions are what separate the top-tier candidates from the rest, but it actually comes down to this specific evaluative topic, the benefits and drawbacks of compilers versus interpreters. That is literally the crucible where top grades are forged. Why? Because this isn't a test of your memory. It's a test of your evaluative logic. When Alex sits down and just lists out, a compiler translates the whole code at once, that's a B-grade answer at best. The examiner is looking for the A-star student who can analyze the trade-offs of that translation process in a specific real-world scenario. That's what we're going to master today.
So, here is our meticulously organized roadmap for today's session. 1. Core conceptual principles. 2. The method mark strategy. 3. Top examiner warnings. And 4. The ultimate exam strategy.
Let's dive right into Section 1, Core Conceptual Principles. The Cambridge Assessment Framework doesn't just want superficial breadth of knowledge. It specifically targets 3 distinct cognitive domains. First, knowledge and understanding. Second, practical application. And third, critical analysis. It is simply not enough to just know what a compiler does on a surface level. You must show practical application and critical analysis. This means you need logical, evidence-based arguments on why one piece of software is fundamentally better suited for a specific task than another. This is exactly where command word decoding comes into play. If the exam question says evaluate and you just describe, you are completely missing the critical analysis domain. Going back to our students, Sam rushes and treats an evaluate question like a describe question. You have to stop and decode that command word. Are they asking for practical application, or are they asking you to critically analyze a system architecture? Knowing which domain you're operating in is the very first step to unlocking those higher mark bands. And this brings us to where logical reasoning truly comes in. We need to do a systematic analysis. On one hand, compilers carry a deep, time-consuming translation overhead up front to create a standalone executable file. But the massive benefit? They run incredibly fast afterward because the code is already translated into machine code. On the other hand, interpreters execute line by line. This means there is significantly less wait time initially when you want to run the program, which is amazing for debugging, but it results in a much slower overall execution speed every single time the program runs. Evaluating these two methods requires you to extract data from the exam prompt and analyze the specific trade-offs of these opposing systematic approaches. If a business needs a program to run 1,000,000 times a day without modification, the compiler's upfront overhead is totally worth it. If a developer is actively writing and testing a script, the interpreter's line-by-line execution is vastly superior. You see the difference? We aren't just reciting facts. We are applying systematic analysis.
Let's move on to Section 2, the method mark strategy.
Algorithmic thinking is practically applied by moving through these 4 critical phases. You design algorithms via decomposition, you implement solutions, you perform rigorous testing, and crucially, you evaluate performance. Whether you are compiling complex C++ code or interpreting a quick Python script, this is the procedural framework that proves your programming skills on paper. And you need to manage your time effectively across these phases using a time management matrix. Don't spend 20 minutes designing if the question only carries 2 marks. Before we continue, subscribe to our YouTube channel, Ace the Exams, at Ace the Exams IGCSE, to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, so getting back to our phases, evaluating performance is usually where students drop the most marks. They can implement a solution, but when asked to test thoroughly and evaluate, they freeze up. You have to show the examiner you understand the entire lifecycle of the software, from the very first line of code to the final compiled executable. The crucial point here is following this standardized, systematic sequence, so the examiner can clearly see you're working. This is what we call the method mark strategy. Look, marks in these Cambridge exams are frequently awarded for the process, not just the final answer. If you identify the key elements, apply the relevant principles of compilers or interpreters, execute your analysis with absolute clarity, verify the results, and present it all in the correct format, you are physically guiding the examiner's red pen to give you those points. This is where the PEEL framework comes in. Point, evidence, explanation, link. If you use PEEL for every major paragraph, you are inherently checking all of these boxes. You make your point, you back it up with evidence from the scenario, you provide an explanation of the technical concept, and you link it back to the question. It completely stops you from doing what Alex does, which is just brain-dumping raw facts without structure. Let's transition to Section 3, Top Examiner Warnings. We really need to address the reality of where students fail. Let's look at the principal examiner reports to see exactly where you might trip up. These are the top 3 mistakes directly from the people grading your papers. 1. Forgetting to check overflow and edge cases. 2. Forgetting to check boundary conditions. And 3. Providing generic answers not specific to context. These top 3 mistakes are exactly what keeps average students at a B grade. But honestly, the absolute biggest trap here, the one that is so frustrating to see, is generic answers. Stating something like interpreters are easier to debug without linking it directly to the specific business scenario in the prompt is a guaranteed way to lose your marks. If the prompt is about a global bank updating their core transaction system and you just give a generic textbook definition of an interpreter, you get 0 for application. You have to tie the technical fact to the specific scenario provided every single time. To prevent these critical errors under extreme exam pressure, take a moment to build a personal mnemonic. We use a simple memory hack. Think of the acronym OEG. That stands for overflows, edge cases, generic answers. When the clock is ticking down and your adrenaline is high, visualizing OEG ensures your foundational framework doesn't just evaporate. It forces you to check all your blind spots before you move on to the next question. Stop scrolling, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCE and turn on all notifications so you never miss our weekly exam strategy sessions. Remember, mastering these memory hacks is like having a cheat code for your brain. When you look at an algorithm, OEG reminds you to immediately look for where the variables might overflow, what happens at the absolute extreme edge cases of the data inputs, and it screams at you to avoid writing a generic response. Moving right along to Section 4, Ultimate Exam Strategy. You must constantly ask yourself this question while writing. I really cannot emphasize this enough. Examiners actively, intentionally penalize generic responses. It is an examiner alert for a very good reason. Imagine we are doing a find the flaw exercise right now. If I show you a paragraph that says, a compiler is better because it is faster, you should instantly spot the flaw. It's totally disconnected from the context. Every single point you make about the benefits of a compiler's execution speed or the drawback of an interpreter's lack of optimization must be tied back to the exact system or business scenario described in your exam prompt. If the prompt talks about a mobile game development studio, you talk about how the compiler's executable file protects the proprietary source code from being stolen by competitors. See the difference? That is a contextual link. That is how you secure an A-star. When you are comparing compilers and interpreters, stating similarities and differences using comparative connectives is the absolute key to evaluative thinking. Look at these 4 rules. Identify similarities and differences. Use comparative connectives. Support each comparison with evidence. Draw conclusions on relative importance. Do not just list facts in isolation. I want you to practice speed writing your answers using words like whereas, conversely, or in contrast. Back up every single comparison with technical evidence from the PEEL framework we discussed earlier. And then you have to take that vital extra step. Draw a conclusion on their relative importance. Why does the difference matter for this specific scenario? It's not enough to say a compiler translates everything at once, whereas an interpreter goes line by line. You have to conclude with, therefore, for this time-critical financial application, the compiler is relatively more important because runtime execution speed is the highest priority. That is a masterful comparative analysis. If you are hit with an evaluation question, remember this precise definition of exactly what examiners want you to measure. You must assess time complexity. Does the compiler heavily optimize the code for faster running? You must assess space complexity. Does the interpreter use less RAM in the given moment since it doesn't create a massive standalone executable file? And you must assess edge cases, like we mentioned with our OEG memory hack. This right here is the gold standard for proving your higher-order analytical skills. When you can comfortably talk about the space complexity of a compiled executable versus the memory footprint of an active interpreter environment, you are no longer just a high school student answering a test. You are a computer scientist analyzing system architecture. And I promise you, when Cambridge examiners read an answer that correctly uses terms like time complexity and space complexity in the context of translation software, they immediately start moving your paper into the highest grade boundaries. To hit those higher-order objectives, you absolutely must demonstrate this kind of deep evaluative thinking. Top-scoring candidates don't just pick one side and argue it blindly, like they are stubbornly trying to win a basic debate. That's a rookie mistake. Instead, they actively consider multiple solutions. They analyze the real-world trade-offs between compiling the whole program versus interpreting it on the fly. They openly acknowledge the limitations of their own recommended approach, and they justify every single decision with concrete technical evidence. If you recommend a compiler, acknowledge that debugging will be vastly more tedious during the development phase. By acknowledging the limitation of your own choice, you prove to the examiner that you understand the complete, holistic picture of the software development lifecycle. This nuanced approach completely transforms how your paper is graded.
Now, what's really exciting about this systematic approach is that it gives you the ultimate step-by-step exam execution sequence to follow on test day. First, you read the prompt and completely deconstruct the question. Apply command word decoding immediately. Second, you extract the relevant contextual data about the scenario. Third, you select your analytical framework like the PO method and the comparative rules we just mastered. Fourth, you execute your answer with clear notation. And finally, you present it using precise, official Cambridge terminology. No slang, no vague descriptions. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by.
So, equipped with this masterclass strategy, are you ready to stop losing easy marks and start evaluating like an A-star student? You now have the exact blueprint that Cambridge examiners use to grade your papers. The next time you sit down to practice, I want you to intentionally avoid the generic traps that students like Alex and Sam fall into. Ask yourself, when faced with the choice between the deep optimization of a compiler and the agile debugging of an interpreter, do you have the precise contextual evidence ready to prove your case using the Peel framework? Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.